Hi everyone, this is Adish. Welcome to my YouTube channel. So in this channel, you gonna learn everything from basics to complicated topics of embedded systems. So first of all, you have to brush the data sheets of a particular microcontrollers while designing it or so here designing and all will be not there. So I'm gonna explain like how to write firmware in IDE using datasheets or the logics. Before jumping into the main topic of the video, please subscribe and like. For writing firmware, we should need MP Lab IDE. So IDE is nothing but Integrated Development Environment. So this IDE is for PIC controllers. So PIC controllers are used by many industries, competitive industries. So no Arduino used by any embedded industries. So Arduino is used by technically saying like the engineers for their mini projects or main projects. So I'm going to explain like what are the controllers that are needed for you to learn. So let us download the MPLab IDE. So I'm gonna paste the link of this how to download this IDE. So let us so if there are Mac OS users or Windows users, there is some options. So I'm using Windows MPLab IDE. So after downloading IDE, we need a compiler for compiling the software, sorry, firmware. So we're gonna download it. I'm gonna paste this one as well. So this gonna take around 5 to 10 minutes. That's it. So after downloading this, you should install. So there is that steps. I'm gonna tell you how to install those. So let us download these applications. So why am I telling that Arduino is not used by any competitive industries? Because of first thing is BOM requirements. So this one is the uh, main page of the MPLab IDE. So let's create a project in this. So you have to go to File, New Project. So we gonna select standalone project for now. So click on Next. My computer is very slow. So next thing is I'm using PIC 16F66F60. So we gonna go through the data sheets of it, and I'm gonna explain what are the things listed there. So after selecting this PIC controller, so tool is nothing but debugger tool, something like that. So next, so don't click that, press none. So compiler tool change. So after downloading, installing that, you're gonna select that and write the project name. So today I'm gonna explain how to blink the LED. So create one folder in desktop, and in that you gonna list every project from now on. So after writing the project name, finish, press the finish. So project has been created. So in the dashboard you can see that PIC 18 F6 has been written, and data bytes program size also been written. So program memory means whatever the code you write, that's much space it can give. So next thing is expand the LED blink project, and you can see the header file, source files. So right click the source file, go to new, see source file. So write the link LED blink file name. So in this file only you will edit the firmware. So click the finish button. So after that, now let's go through the data sheet of PIC 18F66J60. So in the main page, you can see microchip and family data sheet. So microchip is nothing but like it is a industry which produce so much of variety of microcontrollers according to the customer requirements. So here you can see 1 megabit flash microcontrollers with the Ethernet. So Ethernet is a main protocol that is that can be used here. So I'll be explaining this later on videos. So let's get through the some important topics like related to blinking LED. So here you can see Ethernet features, peripheral highlights, flexible oscillator structure, and special microcontroller features. So here they are briefly explaining what and all are here in the microcontroller. So you can see it has timers 0 to 4 and PWM modules and synchronous serial ports, I2C and UART modules, and as well as to digital converter. These are very important for you to learn. So I'll be explaining in future videos. So these are special microcontroller features that are single cycle hardware multiplier or operating voltage range of 2.35 to 3.6. So 3.6 for Ethernet module. So let's get to the main part. So this is the schematic figure of PIC 18F family. So this is where we need to stop. So table of contents. So here everything is explained like it is the agenda of this data sheet. So what are they going to explain? So what are the features they are inside in the microcontroller? So memory organization, flash program memory, external memory bus, interrupts, I/O ports, timer modules, and as well as the PWM module, Ethernet modules. So let us go to the I/O ports. So after going through this, you're gonna get confused. So what have they written? So first thing is tris resistor and port resistor and lat resistor. So tris is nothing but a tri-state. So tri-state is nothing but you can switch between output and input. So if you use tri-state as 0, you will be going to like output. So if it is 1, it is considered as input. So basically default microcontroller, if you don't use citrus, it is considered as input. So here they have explained about what and all ports are there. So output drive levels, port A, F, G, H, D, E, J, B, C. So they have given B and C suitable for direct LED drive levels. So we can use B or C for driving LED. So driving LED is nothing but blinking for our purpose. So lat, so what is lat? The output lat is useful for read or modify write operations, the value that the IO pins are driving. So this is to give output for the LED. So because if you use lat B is equal to something 1, it will make that resist to high level. So LED will glow like that. I'll explain in the firmware. So after this, we require oscillator. So basically oscillators are required for the timing constraints. So oscillator is nothing but frequency, right? So one thing. So frequency is nothing but the inversion of timing. So if you want to blink 500 millisecond or 1 second LED on and off, you require oscillator. So 1 second, let's get back to the first page we visited that time. So here you can see the oscillator configurations. So there are so many types of oscillator, like how high speed crystal oscillator, HSPLL, ESEC, external clock, external copy software PLL, and internal 31 kilohertz oscillator. So if there is no external oscillator, we can use internal oscillator as well. So that is 31. So it can be multiplied as well. So next thing, so these are the basic requirement for blinking an LED. So that's it for now. So why have I have come through the data sheet, because this is the main purpose as an engineer, to study the data sheet of this controller and design accordingly. Hi guys, let's jump into the firmware. So I have already written the firmware for LED blink. So let's get back to the code. So starting is the configuration bit settings, and second thing is the library. So and the third is the frequency setting, and inside the main code I have written the firmware, the actual firmware. So so first thing is we gonna set the oscillator to 8 megahertz. So we, since I have already told you I am using internal oscillator, so you, but I have used the configuration bit for the internal oscillator with PLL. So let's get to the deep of this in the future videos. So as of now, I'm gonna make it simple and basic. So the third thing is like OSCON. So OSCON is the register. In that, if you add 0x72, it is a hex. So if you add 0x72, it will make 31 kilohertz to 8 megahertz. So then, so using this 8 megahertz, we'll blink the LED. So I'm gonna give you some exercise. So what is the 8 megahertz means? What is the conversion into time? So comment that. So next thing is set port B as an output. So I we have already discussed in the data sheet. So B and C used to drive LED. So I am choosing B0 as an output. So tri-state B bits dot tri-state B0 is equal to 0. So 0 means it, we are converting port B to output. So first thing, so next thing is lat bits lat b 0 equals to 0. So that is that meaning. So I already told output LED should be 0, first thing, level low. So we are initializing this. So inside while loop. So in order to blink the LED in a continuous loop, we are using this while loop. So while true, inside the brackets lat b bits dot lat b0 is equal to LED on, meaning, so LED on is defined in the header file. So I'm gonna tell you how to add that. So after I'm giving delay 500 milliseconds. So after that I'm going to switch off the LED. So after turning on for 500 millisecond, I'll be turning off. After that I'll be turning off 500 milliseconds again. So this will be in the loop every time after you dump the code in the microcontroller and power on. So this is the basic and simple firmware explanation about the blinking LED. If you guys have some doubts, please leave a comment in the box. So I have already told you here, if you, this is the error you can see if you make an error in the code. So this is just to explain how to find the error and debug it. So LED on, LED off. So I have never listed this LED on and LED off here. So I have given in this LED blink dot h. See here, LED on is 1, LED off is 0. So in order to add this file into the LED blink dot c, just like adding library, you add a header file. So I have missed Anna. So it is only giving the recommendation. Just print enter. No, see now it has vanished. So this is the simplest explanation for the firmware LED blink using PIC microcontroller. So after doing this all, you just want to build it. So clean and build. So here it will clean and build in this prompt. Oh, I'm seeing some error here. So after pressing the clean and build, you're gonna see in this prompt. So here go, clean successful and also build successful. So meaning the code is very what is bugs fixed and there is no error in it. So loading completed. So what is loading completed? I'm gonna explain this. So loading code means there will be a hex file for every project you build it. So this hex file can be dumped in another programming environment. So I'll be explaining in another video. So where you can load this hex file into your microcontroller through the programming application. So right now we gonna use the this button. So this is nothing but if you connect your card through the connector, programming connector, that is Picket debugger. So if you click this green button, so it will automatically run the main project and the code can be dumped. So ending the video.